Hey guys, let's get started looking at number one here. Number one in this particular SAT prep lesson, this was our inequalities section. We are going to see that the answer is B, and this is considered easy because this is stuff that's pretty straightforward. What you would do here is actually solve for the J variable in this inequality. So when we solve, we're actually not looking for an answer. We're going to look for like an interval. We're not looking for like J is 5. We're looking for an interval of some sort that's given here. So I'm going to put J on one side. Let me move the J's to the left and the constants to the right. So I'm going to subtract 6J from both sides. I get negative 3J minus 4 less than or equal to 11. Adding 4 to both sides to get rid of the 4 on the left, I end up with negative 3J is less than or equal to 15. When I divide both sides of an inequality by a negative number, as I'm doing here, automatically the sign flips. And that's something that you need to know. That was something that you were definitely taught in your algebra class. So the sign flips, and now J is greater than negative 5. And so you can see why our answer is B. Let's take a look at this next one. So number 2, the answer is D, negative 2. Which of the following numbers, now here's something that you need to pay attention to, is not a solution. So it does not work here. You literally can actually plug each of these values in and see which one doesn't satisfy the inequality, doesn't make this side greater than or equal to this side. Or you can manipulate the equation, which is what we're going to do with algebra. Again, I'm going to try to isolate x and solve for it. When I do that, I'm going to subtract 6x on both sides. I'm left with negative 9 is greater than or equal to x minus 5. I'm going to throw the 5 over to the other side by adding 5 to both sides. When I do that, you see I get negative 4 is less than or equal to x. So I'm going to bring it over here and think about it. If negative 4 is, is greater than or equal to x, that means x is less than or equal to negative 4. So any answer that is less than or equal to negative 4 works, but we want answers that do not work. This is less than or equal to negative 4. So is this? This happens to be equal to negative 4. Clearly negative 2 does not fit this, therefore it does not fit this, therefore it's the answer we're looking for. Let's take a look at number 3. In number 3, the answer is H is greater than 4, and let's see if we can figure out how to make that happen. So we see that we've got two people, Melly and Ron, and they both have different charges for their babysitting operation or something. So $5 for gas plus $8 per hour is Melly's charge, and Ron is $3 per gas plus $8.50 per hour. And so what we're trying to do is figure out what values of H would make Ron's charges higher than Melly's charges. So what I see is that like there's an initial higher fee of $2, right? Like he charges 3, she charges 5, just initial fee before even the hours start taken away. After 1 hour, he only makes 50 cents more. So clearly it's not going to be like this category. After 2 hours, he makes $1 more, still not compensating for the $2 difference. You with me? After $3, because you with me? Because he's only making a little 50-cent more as we go along. So I can already isolate this, that this value doesn't work out. What I can do now is just actually start substituting in the different intervals, because this is not something that I can quote solve for. I mean, I guess I could kind of think about a way to solve for it, like do like an inequality, when is this side greater, and kind of move through it. I guess I could do that. That's a possibility. I'm not going to do that this time though. I'm actually going to just choose values and plug it in. So from 3 to less than or equal to 4, like if I were to put 4 into this inequality, because that's a part of this interval, if I put 4 here and a 4 here, you'll see that the only thing that happens is that he gets $2 and they're actually equal. So at 4, they become equivalent. At, let me see if I can make this. All right, so I calculated it out, and if I plug 4 into each of their equations or their expressions that represents the money that they make, we get 37 and 37. We want to know when Ron makes more. So this can't work because the highest we get is them being equal. And this technically doesn't work because, again, 4 is involved. 4 is a part of the solution, and we want to know, we want an interval where all the money, well, every value is going to represent Ron making more money. So it has to be D. You see what we did? All right, I hope that made sense. Let's keep it moving. So looking at number 4, We take a look. We see that Yasmin is a pharmaceutical sales representative. Her firm gives her a weekly allowance of $300 to spend on lunches with physicians and their office staff. A restaurant from which Yasmin often buys lunch charges $7 for cold dish, $11 for a hot dish, including drinks. If each meal is subject to a tax of this amount, which of the following inequalities represents the number of cold dishes, C, and the number of hot dishes, H, that Yasmin can purchase here? And so part of these types of problems is looking at, having an idea of what the answer would be and looking and to see if your answer choice is represented. So what we know is that if each meal is, if you're going to add a 5.75 sales tax, what that means is you're actually going to be charged the original price, 100%, plus an additional 5.75%, right? So technically you're dealing with 105.75% of the original price. Just stay with me for a moment. I hope that kind of makes sense. You got to pay the original and you have to pay this extra 5.75, which is the tax. And so as you think about this, we recognize that $7 for each cold meal plus $11 for each, I don't know, was it a hot dish? Yeah, for each hot dish, I'm going to actually have to pay 1.0575, right? Does that make sense? 100% of the cost plus a little bit more. And that has to stay underneath or equal to the $300 allowance that she has. I hope that made sense. All right, I had a little sneeze break there. Okay, number 5. If 5, 6 is less than or equal to 1/2 x minus 1/2 y, which is less than 3/2, then what are the possible values of x minus y? When you have a problem like this that just seems impossible, you got to stop and realize that nothing on the SATs is impossible. No problem is going to be beyond you, and there's always a fix. What I noticed here is that x minus y is secretly hidden here. We could look at this expression or this inequality and write it as 5/6 is less than 1/2 the quantity of x minus y, which is less than 3/2. All I did is kind of like the reverse distributive property, or I factored out that 1/2. So these are equivalent statements. Now with that in mind, what this helps me see is that all I have to do is multiply everything by 2, each part of this inequality by 2, and I get my x minus y free. So when I do that, I get 2 times this guy gives me 10/6, which is less than or equal, well, not equal to, I'm sorry, I added that by mistake, which is less than, when I multiply 2 times 1/2, I end up with just that 1. So that's 1 times x minus y, which is great because that's what I want. When I multiply 2 times 3/2, I end up with 3. Because I have this interval, which can be then reduced to this, obviously you can't put this answer in here. The computer will mark any answer between these two values as cool. The most convenient one is probably 2, but I guess if you did 2.5, 2.97, whatever you like, it would be fine as long as it's within this interval. 3 would not work, obviously. 1.66, which is 5/3, kind of written as a decimal, would probably not work because it's more like the answer and not within the interval. All right, beautiful people, let's keep it moving. So as I look at this one, what is the least possible integer for which 40% of the integer is greater than 9.6? I think that this is only considered a medium problem because it sounds kind of complicated, but it's not that bad. And most people are kind of, or many students are kind of feeling uncomfortable with decimals and fractions and percents. But this is not a hard problem at all. So it says basically 40% of which of these numbers is going to be greater than 9.6. And so you can just check out 40% of each number. Remember to calculate 40%. Basically, you're going to multiply by 0.4. You can use a calculator so you see you can rock this out really fast. So 4% of that is 1.6. And by the time you get something low like that, you want to move up to something higher. If you did 40% of 12, you'd get 40% of 12, you would get 3. Would you? No, you wouldn't. You would get 4.8. I'm just lying to people. You get 4.8. If you did 40% of that, you'd get 8. If you get 40% of 25, you get 10. And so you can realize that that's the answer. So really it was just like, hey, can you use a calculator? Can you figure out percents? Can you understand this problem? Number 7, the answer is A. And so we're going to talk about the body mass index. So here we have a high BMI can be an indicator of high body fat, which can lead to health problems. According to the American Heart Association, an adult is underweight if the BMI is less than 18.5, or overweight if it is greater than 25.0. Which of the following number lines could be used to model a healthy person? So the underlying bit of information is that we're looking for somebody healthy, and somebody underweight is therefore considered not healthy, and somebody overweight is therefore considered not healthy for the context of this problem, right? So if we know that an adult is underweight if they are less than 18.5, less than 18.5, 18.5 is going to seem like a cutoff for health, right? So if you're 18.5, that's the lowest you can go. And then it says overweight if you are greater than or equal to 25.0. So at 25.0, that's not healthy. As soon as you get there, anything before is cool. So we need to figure out an inequality that represents that 18.5 is cool, 25 is not cool, right? And everything in between is okay. And so that's why this one's the answer. The other ones, this one looks like they're identifying what unhealthy is. This one doesn't actually show us the proper open and closed situation. Like this one does not include 18.5 as our statement does, whereas this one includes 25 and our statement does not include that as a healthy BMI. Is that making sense? And this one also kind of flip-flops the unhealthy range. All right. Let's look at this next guy over here. Which of the following correctly describes the possible values of K in the inequality above? For something like this, I'm actually going to solve it. I'm going to take my time and work it out. This is honestly very much like a proportion. And we remember that if we have a proportion such as A over B is equal to C over D, an equivalent way to rewrite that is that we can do, it's called the product of the means is equal to the product of the extremes, or basically cross multiply those bad boys. We can do that. A times D is AD. C times B is CB, and then I rock out and I do whatever I need to do. We're going to handle that over here. So I'm going to simplify this as best I can. 2 times 4K plus 1, all of that over 3 is greater than or equal to, 6 plus 5 is 11, so I'm just going to write that as 11K. Minus 3 over 2. This is as simple as I can get either of these. No, it's not. I should have distributed that. Let's make that happen. Okay, so that's better. So now I'm going to cross multiply, and I'm going to do that, and I'm going to use the distributive property for each of these bad boys. So 2 is going to multiply through 8K plus 2, and when I do that, I end up with 16K plus 4 is greater than or equal to 33. Notice I'm multiplying this through 33K minus 9. And I can solve this by moving things around. Let's move our 16 over to this side. When I subtract 16 from this side, 16K that is, I get 17K. And when I add 9 to both sides, I get 13. I'm being a little bit quick with the movements. I hope you're following through. And then I have 13 over 17 is greater than or equal to K. And which one represents that? Sometimes we get a little bit confused, but remember, if I like flip this whole thing over, I gotta flip it over and the sign actually flips over too. Remember that K is less than, so we're looking for a K is less than situation. And that's this one. K is less than 13/17. All right. Okie dokie. Okay, so after reading over this problem, we recognize that the teacher wants to create 2 different types of tests, non-calculator and calculator. We know that she wants to make at least 8 tests. We also know that she has a certain amount of hours. She thinks it's going to take her 3 hours to make one type of test, 4 hours to make the other type of test, and she's committed to having 6 hours per week, given 5 weeks to create these particular tests. So the question is, given that she wants to make 8 tests, which of the following system of equations can help her determine how many of each type of test she can create? So as I look at the problem, I want to make sure I know what the variables stand for. N is the number of non-calculator tests, given the fact that that's what we're dealing with, and C is the number of calculator tests. With that in mind, we know that altogether we want to make at least 8, so that's N plus C, the number of calculator tests, non-calculator tests, must be greater than or equal to 8. At least means we can do more. So clearly, this is not an answer choice and this is not an answer choice. So I've eliminated those, and the next thing we need to do is figure out how much time she has. If she's got 6 hours for 5 weeks, that means she's got 30 hours to make these tests. And so you can see clearly that this is going to incorporate that 30, and we know that there's 3 hours to make the non-calculator test, 4 hours to make the calculator test. This answer just makes sense.